Continuing with the test review questions, test 2 review question. So we did the modeling question. So remember, for modeling, you need to know information about the areas and perimeter and volume of some basic shapes. So remember the area of a square, area of a rectangle. So all these formulas it is expected that you should know, and volume of the box, for example, or volume of a cube. Now, volume of a sphere, if you don't know that, it's okay. If a question comes which requires you to use the volume formula of a sphere, we will give you. But you should know basic things like if you have a right triangle, you can use the Pythagorean theorem if needed, or if it is helpful, formula for area of a triangle. And then you should know that in a right triangle, these lines which are intersecting each other at 90-degree angle. So this is the 90-degree angle. So the side A, B, these are called the legs of the triangle. Now this is only, the legs are only used in a right triangle, not like in any triangle. Okay, generally we don't call them legs, those are sides, but for a right triangle we sometimes call them legs of the. Okay, now looking at number 3. So when you get a question like that, note here the function given is a quadratic. So in your class at this level, the only type of question this type of question you will get only with a quadratic function. When you go to Calc 1, then maybe you can actually find the min and max of functions that are higher than quadratic degree, like degree 2, and also you can find the min max for other type of functions as well. But here we only look at quadratic, and remember the quadratic function gives us a parabola. If we graph it, so it's going to be either like this or like that. So now this, if you have this shape, you'll get a max value, and if we have that shape, then we get a min value. So if the question is asking for the quantity to be maximized or maximum something, and then what do you need to figure out? You basically need to find the vertex. So in both cases, whether we have to find the minimum value or the maximum, we have to basically find the vertex. Now, in order to find the vertex, as explained in section 3.1, you can actually do it by using by completing squares. But often these functions given are not that easy to complete square. So we can use the formula, vertex formula, remember. So x will be equal to minus b over 2a, but what is a, what is b, and what is c? C is basically not used in the calculation, which is okay, but we need to know what is a and what is b. So remember, a is the coefficient of the x squared term. So our a, I will start by writing a, b, and c, and then we will use them in the formula. So a in our case is negative 2 over 5, b is 12, and c is negative 50. So x equals negative b over 2a. You have to remember this formula, and you should write it when you are finding the value. So negative 12 divided by or I can use a straight line. So negative 12 divided by 2 times a. A is negative 2 over 5. So what does this become? This gives me negative 12 divided by negative 4 over 5. Negative and negative cancel, makes it positive, and then 12 divided by 4 over 5. So it becomes 12 times 5 over 4, which will give me 15. Okay. Then we have to, so it means how many units must be sold. So there should be 15 units. 15, 15 units of the commodity should be sold in order to find the maximum profit. Now I hope you remember that since A has a negative sign, so our shape of the parabola will be like this, inverted parabola. So what is the maximum profit? So the maximum profit you have to calculate by plugging this in for the x value in the function. So P of 15 is equal to negative 50 plus 12 into 15 minus 2 over 5 into 15 square, which is 225. Now simplify. This is first quantity is negative 15. Second is positive 180. And then next one is, because this 5 goes in, 225 is divisible by 5, or we can say 5 goes into 225. How many times? 45. Now 45 times 2 is 90. So negative 50. Sorry, the first term was 50, not 15. So 50 and 90. We now say that the maximum profit is. So in word problems, try to answer a final answer as a statement. The max profit is equal to $40. And also do not forget the units. Okay. So there will be a question like this on the test, where you have to basically find the vertex. So the formula is same whether we have the parabola facing up or parabola facing down. You have to remember the units, and you have to remember in which part you will do the calculation, this calculation, and in which part you will do this calculation. Remember, the units is basically the value, the x value, or the independent variable. And the maximum quantity, that is your y variable, or the y coordinate, or the dependent variable. Now, often the way the question appears in exams, I have noticed that they switch A and B. They put B first and then A. Now, in order to find the maximum profit, if it is given in the first place, you have to start here. You have to first find the x coordinate of the vertex. So all this work will be done in part A. If they put question of this type in the first place, and then later they ask about the unit. And the unit, that work you don't have to repeat. You can just mention that as in part A, the, the number of units to be sold is 15 in this, for example, in this question. Okay. Now, the next example is sketch the graph of the polynomial. Basically, there are few things that you need to show or work on. Although, if you know the zeros, so the first thing is find the zeros. Well, zeros are, if you get a polynomial like this, they are right there in front of you. But also you should know what is their multiplicity, because the multiplicity of the zeros show how the zero is crossing the x-axis. So I'm going to write 0 and then multiplicity. So the zeros are, you can see from the first one, is x is equal to -1. Then from the second, x is equal to 0. From the third, x is equal to 1. So the multiplicity of the first 0, how do you figure that out? You go to the polynomial and you look at the factor that gave you that 0. So which factor gave us this 0? X is equal to -1. The factor x plus 1. So you look at the what is the power on that factor. So you can see there is no power here. So we will say the power is 1. So the multiplicity of -1 is 1. How did we get the 0? Which factor gave us 0? The factor x cube. So x cube is equal to 0 gives us x is equal to 0. So what is the power on that factor? X to the third. So power is 3, so multiplicity is 3. Okay, the next is the x plus 1, x minus 1. And the power on x minus 1 is 2, so the multiplicity of the 0, 1 is equal to 2. Now, what you have to remember is that when you have an odd multiplicity, like these are odd numbers, the graph will cross the x-axis. When you have an even multiplicity, the graph will come to that 0, but then it will bounce back. So if it is coming from above, it will bounce back, go up, and if it is coming from bottom, it will touch the 0 and bounce back, go down. So at this stage, you can try to graph the function, but it's better to do a little bit more work. And what is that work? And there are points for that. There are points for writing this, although the question doesn't ask you to, but you should know that you cannot just guess the graph. Okay? Or if you get some function which you already know what the graph because you practiced, so you are not supposed to just draw the graph. You are supposed to show these extra steps. So the next thing we do is we can do a sign chart. If you notice, we can do a sign chart. So, but also another thing that I want you to show is the end behavior. The end behavior. How do you find out the end behavior of a polynomial? So you look at the lead term. Lead term. And how do you find the lead term? Well, if I expand this whole polynomial, if we expand, now this is not like a big deal. This is not like a hard problem. For example, we can easily multiply x. So we have x plus 1 times x cubed. So I'm going to multiply these two. So I get x to the 4 plus x cubed And then x minus 1 whole square is x squared minus 2x plus 1. Now we multiply these two expressions. So x to the 4 times x to the 2. So this with this gives me x to the 6. Then I multiply x to the 4 with minus 2x. So minus 2x to the 5. And then we multiply this with the last constant term. So we get plus x to the 4. Now take the second term in the first expression, x squared, and multiply it with this, then with this, and then with that. So we get plus x. So this was x cubed, so x5 minus 2x to the 4 plus x to the third. Combine the like terms. So you note here x to the 6. That is the only term with the power 6. Then we can combine these two. It gives me negative x to the 5. And then we can combine the 4. We get negative x to the 4. And then plus x cubed. So now notice that the lead term is this one. Now I was going to show you that you can actually find the lead term in a quicker way, and that is what you will do, the quick way that I show you. You are not going to expand the polynomial because it will take a lot of your time. And this time it was simple polynomial, but if you have more mod factors or higher powers, then it will become very hard to finish the multiplication. So this is what you will do. You will say lead term is equal to, so here we will writing it here, so I will just use that. Lead term is equal to, okay, so this is what you will do. Look at the first expression or first factor, that is x plus 1. So what is the lead term in that? X. So you put that here, just x, multiplied by, the next is x cubed, so x to the third. So that is the only term that is the lead term in that polynomial. So we will bring that here and put it like this. And now we will go to the last factor, which is x minus 1 whole squared. So what do you think? What will be the lead term in that when you expand it? It will be x squared. So x squared. Now you multiply, gives 3. So what do we get? X to the, what happens to the powers? They get added. So we get x to the 6. This is how the function is going to behave, and that's what we were getting here. So what do we do now? Once we know that there is a lead term is x to the 6, so then the next thing you have to do is show the end behavior. And how do you show the end behavior? Remember, you can have a sentence in the sentence form, or you can make a little picture. Yeah, you can do it with a, I'll show you. Okay, so we are looking at the end behavior. So x to the 6. Now again, this is something you should know from chapter 1, that these type of functions just one term, and then we have powers. It can be any power. For now we are dealing with only the positive integer power. So if you have this type of function. These are, let me write one more. These are called the power functions. And if the power is odd, so power is odd, that means it could be 3, 5, 7, 9, 11, so on. The function will, the graph of the function will behave the same way, or it will look the same as graph of x cubed. Then graph is look like the graph of x cubed, which means something like that. The only difference is now that, so if this is x cubed, the difference with x5 will be a little bit flatter at 0. Maybe a little bit more like that. And as the power increases, it becomes more and more flat. Right? So if we go to higher powers, it look like almost like sitting on the x-axis like that. And if the power is even, it means it's 2, 4, 6, and so on, then what do you think? Graph is like the parabola. So what will happen again? If this is x squared, then x to the 4 will be a little flat, and then x to the 6 will be even more flat, but the shape will be same. So what is the end behavior? End behavior means when x is going to infinity, for example, in this case, where is your y going? So can you see y is going up, 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 up? So x goes to infinity, y goes to infinity. On the left side though, x goes to minus infinity, y goes to infinity. So you can either put it in terms of in words as I just said, or you can draw it, not graph like this, but arrows at the ends. I will just show you. First, let's decide what our function graph look like, or end behavior. So we have x to the 6. So it will behave like one of these down here. So this is how we will show the end behavior. So we don't draw it over here because our function is not just x to the 6. It has some other terms as well. So it would not be like that. Okay. So the next thing we do is I'm going to erase this now. Actually, I will add a page. Okay. So we saw that the end behavior is so this is what we do. We can say as x goes to infinity, y goes to infinity. as x goes to negative infinity, y goes to infinity. So you have to write it as like this, or you can do this. That is means the same thing. Now we make our sign chart. Another thing that we could have done is, actually we will do is find the intercepts. So 4 things: zeros, and behavior, zeros and their multiplicity, and behavior, um, intercepts. Now intercepts, basically we have found the x-intercept and we found the zeros. So those are your x-intercepts are the same as your zeros, but y-intercept would be different. So there will be only one y-intercept. There can be more than one zeros or x-intercepts. Sign chart. So what will you put on the line? Just the zeros, because those are your critical numbers. So these are called critical numbers. Zeros of a function, or a function where the or values, numbers where the function is not defined, or the function has vertical asymptotes. So sign chart. So I'll put -1, 0, and 1. So remember, our function or our polynomial was x plus 1 times x cubed, and then we had x minus 1 whole square. Now when we are trying to find the sign chart, we don't need to consider this one because it's a square. So no matter what x value you use, that will always give you a positive sign. So positive times whatever the sign of this is, and times whatever the sign of the next one is. So what is the sign there? Can you see that? So when I pick a number on this interval, so let's say -2. So when I plug -2 in the x plus 1, I get negative sign. When I plug -2 in this one, I get negative sign. So negative times negative is positive. What about the next one? Between -1 and 0, can pick 1/2, -1/2. So when I plug in -1/2 in here, I'll get a positive sign. But with x cube, I'll get a negative sign. So I'll get negative. Now between 0 and 1, it's like 1/2. So 1/2 is positive times positive, so it is positive. What about over here? Now we have, again, we can put 2 or 3. So everything is positive. So this is the sign chart. As I said, x-intercept, you already know. These are the x-intercepts. And now, what about the y-intercept? Remember, for y-intercept, we set x is equal to 0. So when you plug in x is equal to 0, where y will be equal to 0 plus 1 times 0 cube times 0 minus 1 square. Now, the first one gives me 1, the second is 0, 1 into 0 into 1, which is 0. I don't even have to do all this work, I can just say equal to 0. Okay, so now we can try to graph the function. So what are the 4 things you have to show? There we are. So this is the first thing. 0 with their multiplicity. Second is the AND behavior. Third is the sign chart. Fourth is the intercepts. And now try to graph the function. Draw the y-axis and the x-axis. Now we notice that the sign chart, most of the time, or most for most values of x, the function is above the x-axis. So I don't need to go far, down below the x-axis. So I'll put my x-axis somewhere here, not in the middle. Now we can just estimate the y coordinate here. 2, 4. Not taking like tiny scale spaces. Take a big, nice step. So these are called steps. So don't be don't choose tiny steps like this. Big steps. Okay. And always put tick marks and always put some numbers at least. I usually put all the numbers here, but you guys at least some numbers. Okay, so now to graph the polynomial, we will first point out the zeros. So zeros are at -1, 0 and 1. So if you remember, the AND behavior told us that the function is going to be over here and over here. Which means it should be coming down from up there. Now, where do you make it come down? Like, should you make it come down like this? Or should you make it come down like this? That's your choice. It should not look like a straight line like this, because straight line, vertical line is not a function. So, and then you have to check. This is a 0 of multiplicity 1. So the graph is going to cross the x-axis. But how will it cross? It will just cross like this. Okay. Now the function has to come back to this next 0, which is the 0, 0. It has the coordinates 0, 0. So the function has to come to. So it means it has to turn somewhere. So we make a turn here. But now this 0 is of multiplicity 3. So it's not going to go like that. That will be wrong. Okay? So I have to modify previous one over here as well. So we are going to make it go like something like this. Okay, now it goes up, but should I just let it go up? No, then what about the zero? This zero, which is 1, 0. What about that? So it means the function has to turn and come back to this 0. So how will I do that? Well, you cannot make it go like this. You have to modify it. So let me erase this just to show clearly. So what you are going to do is you are going to make it come back like that. But then what? Then again the function should go back up. Why? Several reasons. One reason is that the multiplicity of 1 is 2. So it has to bounce back. Touch the 0 and bounce back. And then also the end behavior showed us that the function over here should be going like that, not like this. Not like this. Okay? So what do I do now? See, again, we are in a little bit trouble. So you are not supposed to do something like that, like, so that this looks like a corner. That shouldn't happen. Polynomials never have corners. They are smoothly flowing functions. So how do I then go from here? Well, that's why I keep saying choose bigger scale. So for now, this is what you can do. Erase a little piece from there. Do it again now and something like that. But I'll show you if we had taken the bigger scale, the graph would look much nicer. So for example, if instead of taking this as 1, if I take this as 1 and this as -1, then okay, so we have this is -1 and that is 1 there. Okay, so now we have this as our 0 and this is 0 and this is 0. So we make this come like this, pass it through this 0, goes down. Now you can also plug -1 in your function and try to see what the value is so that you can get an idea. Do I have to turn from here or do I need to go a little bit here? Although if you do any of these things, it should be okay. You won't lose points. So if you didn't find the value at -1, that's not a big issue. Sorry, not -1. This will be -1/2. Right? This will be -1/2. Yeah. So now you do that. But remember, you have to be like this over here. So this behavior should be very, very clear over here. This behavior. Okay. Okay. So we have this portion done almost. Now what? Now the function has to come to this one, right? It has to go like that, but then what? Will it go? No, don't go like that. It has to remember touch the zero and bounce back. So something like that. That, see, now it looks much better than earlier. So this is how you draw the functions which are polynomials. Okay, see you in the next video.